So friends, before going into the actual algorithm of merge sort, so before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. We saw that in divide step, we saw that we break the array into two parts or into two sub problems, and that we do recursively. So at a high level, I will simply show you the code. So this code we will be discussing in a greater detail with an animation in our upcoming video. But just for understanding that how it works. So when we break the array into two parts, we are not actually breaking the array from here. Let's say from 0 to 3 it goes like this, and from 4 to 6 it goes like this. We are breaking it based on the three pointers, let's say low, high and mid. So usually array remains the same, and we have something like, let's say, low points here, mid points here and high points here. So from low to mid we consider that this is the sub problem, and from mid plus 1 to high we consider it as a different problem. But the array structure remains the same. It's only the pointers which decides which is the left part and which is the right part. So here you can see in the sort method, this method gets called two times recursively. So one is for going into the left side and one is going to the right side after breaking it based on the mid element. And as this sort is recursive in nature, so here you can see usually at the start low points to 0 and high points to the last index. And let's say if we calculate mid, so here it will be 0 plus 6 minus 0 by 2, which will give us 3. So mid comes out to be 3. So for example, let's say we calculate mid as 3. So this division here is done based on calling of these two sorts. So what we do is, so when we call this sort, we pass the ranges from low to mid. So low to mid. So it looks like that we are doing like this. And for the right subarray, it says from mid plus 1 to high. So this is the mid plus 1 to high. So it looks like this. But the array remains like this only. It's actually the logical division based on low, mid and high pointer. And this we do recursively. So when we call this, we actually get this. And it again does the same thing again. And here you can see it again recursively calls this. So this is low and this is mid. And this is mid plus 1 and this is high. So it goes on like this till we can't divide them further. So this condition, low less than high, help us in preventing that. So here if you see, low and high point to the same. So we simply return from this, and once we return from this, it goes here, then this sort is called like this. And here similarly this condition help us to make it come back. So after these two steps end, we actually merge the two sorted arrays. So these are the sorted arrays, and you can watch my previous tutorial that how we can actually merge the two sorted arrays. But in merge sort, we actually take the help of a temporary array which help us in merging the two sorted arrays. So this we will discuss in a greater detail in our upcoming videos. But here we will simply see a high level view of merge, how it is actually done. So here you can see that we saw that at the last step we take this sorted array. This is the left array and this is the right array. And we usually merge it. So we do something like this. We compare the elements in the respective arrays and we fill out the array like this, and this is our answer, that we get a sorted array. So this is done via merge method. Now let's see how we can take the help of temporary array and merge it. So this is the same thing which we saw in our previous slide. So this is the left part and this is the right part. So these are distinguished based on these colors. So usually how we merge it, we create a temporary array of the equal length and then we first copy all these elements like this. So here it looks something like this. So after we copy every element like this, now what we do is, this array is our original array. We have took every element in the temporary array. Now we create the pointers which traverse to left part and the right part, and based on our comparison, the original array is actually filled. So I'll just remove this. So here we take I for this left part and J for this right part. And how we actually fill is, in the original array we start from here, let's set K. We compare 2 and 4 denoted by I and J. So 2 is less than 4. So we know that 2 will take this position like this. And we are done with this part. So we increment I. And we also increment K because we are done with this filling. Now we compare 3 with 4 and 3 takes this place. We are done with this element. So we increment I. We don't increment J because these values are not filled up. And you can watch my previous video where we actually saw that how we can merge two sorted arrays. So this is the first sorted array, this is the second sorted array. And the concept remains the same when we do the merge sort. So after filling 3, we increment K and then we again compare 5 and 4. So 4 is smaller, so 4 takes this place. So we are done with this element. So we increment J. And here similarly we do the filling. So in the next iteration 5 is less than 6, so 5 comes here. We increment I. We increment K. 6 is smaller than 10, so 6 comes here. We increment J. Then 10 comes here. And here you can see, after filling 10, this element also gets filled. So now there are no more elements left in the left part. And here you can see that we have only left with 11. So this goes out of the boundary. And whatever the values are left in the right part, we simply put it here because they are already sorted. So anything which comes after 11 will be, let's say 12, 14, XYZ, but it will be greater than 11. So they will come directly like this. So we simply copy the elements in the leftover part of the original array. So it goes like this. So this is the merge at a high level using the temporary array. So friends, there are two cases which we need to see. So the case one is when the left array is exhausted. So here you can see, after filling 2, 3, 5 into the respective position and even 10 here. Now here left array is exhausted. So we don't touch this now because everything is filled up here. And here you can see, as we copied all the elements like this, in the original array, if you see 6, 7 and 8, whatever the values are here, those were actually sorted. And when we actually copied into the temporary array, it came it like this only. So here you can see, we don't push it back like this because the right array values are already present in the original array in the same order, 11, 12, 17. So we do nothing here. Once the left array is sorted, we do nothing because right array is already having the elements here which are already sorted. Now case 2 comes when right array is exhausted. So here you can see 4, 5, 6, 10, 11. These are all exhausted till this point. So after putting 11, J goes out of this array and K comes to this part because we need to fill 2 more elements and our right array is exhausted. So here you can see that when the right array is exhausted, we have to do something to push left array elements into this 7 and 8th position. So how we do that? We provide a small code which is like this. So here you can assume that mid is this point and I will go till mid, and we simply copy the leftover elements into the respective places using the I in kth index. So here you can see in the original array at kth index we are assigning temp of I. So this is the temp and this is the I. So 12 will go to array of k like this, and then we increment both I and k. So k will go here and I will go here, and this while loop will continue, and we'll simply put 15 at this position by this assignment. So after that this while loop will terminate. So friends, here we need to keep these two cases in mind, that if left array is exhausted we do nothing, because when we copied the element into a temporary array, when the left array got exhausted, the right array leftover elements were already present in the original array and that too in sorted form. But in case 2, if right array is exhausted, so here if this array is already exhausted and all these elements are present here and there are elements left over in the left part, so we need to provide some additional code like this to put it into the respective places. So we will see this algorithm in much greater detail in our upcoming video, because that is very complex algorithm. So I just demonstrated at a high level that how it looks. So when we will discuss that algorithm, we will see all the details of sort method, merge method, and how this sort method recursively calls itself and basically divides the array into two halves, and later when the two halves are no longer divided further, then how we actually merge them. So friends, I hope till this point you must have got a high level idea of how merge sort works. In our upcoming video, we will see a detailed animation of merge sort algorithm which will make this idea more clear to you. You can watch this video 2 to 3 times so that you can get an idea of the merge sort at high level. I hope you must have liked this video, and in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day.